Thank you. Today we're going to be doing question 8 of the November 2024. This is Physical Sciences, Physics Paper 1. And then we have the term there, they said 8.1. Define the term power. So we're trying to define the term power. Define the term power. So to define the term power is simple. Remember, we know that power is equal to W over delta T. This is the rate at which work is done. The rate at which work is done. At which work is done. I believe everyone got this correct. The rate at which work is done. And then we're done. Then 8.2, we're now dealing with calculations. 8.2.1. They said reading on ammeter A2, if both light bulbs operate as rated, calculate the reading on ammeter A2. So the reading on ammeter A2, what is ammeter A2 reading? Let's look at A2. There's A2. So A2 is reading the current which is passing through the light bulb 2. And when I look at light bulb 2 as given these ratings, they said L1 and L2 are two light bulbs that have the following ratings. So if L2 is rated like that, it means that the power of L2 is going to lead us to the current flowing through L2. Power is I, what is it? This is going to be VI. Power is VI. And we know that from the formulas. So using that formula, I'm going to replace my power, which is 48 watts, and then my V is going to be known as, it was given as 32. So I'll just plug 32 and then I. Then my I will simply be 48 out of 32, and that is going to be my answer. When I punch the calculator, I'm getting 1.5 amperes, and that is correct there. We are done. 8.2.2. 8.2.2, reading on ammeter A1 with A1. There's A1. So my A1, I need to check the reading there. So this is going to be the current flowing through, what is it? When I look at it, this is the current flowing through the main circuit. So you can see this is going to be coming from there, and then it comes here. So that's going to be I main. So to calculate that, I know that this current came and divide here on this junction. So when it's dividing, it gave us two currents, which was I, what is it, L2, and then the other one was I, L1, which was I1. So the summation of these two will give us, what is it, I2 plus I1 will definitely give us our main current, which is going to be IA1. Okay, so I already know the I2. Is that I2? Yes, I already know I2 is 1.5. So now I just need to calculate my I1. I1, I'll use the same formula of power because L1 was given a rating. This L1 was given a rating of 36 watt and 20 volts. So I'm going to take that and say plus, this is going to be 36 all over 20. And then I need to get an answer of how much. I don't know as of yet. I'll punch the calculator just now. Okay, I have 1.5 plus, and then when I punch the calculator, 36 all over 20. 36 all over 20 is giving me 1.8. So I have 1.8 amperes there. So this is going to be IA1. When I add these two, I can notice that's going to give me 3.3. So 3.3 watt amperes. So that's going to be my IA1. And this is the main current. And then we're done. Okay, we're okay with 8.2.2. Now 8.2.3. What is happening with 8.2.3? 8.2.3, they say the resistance through, what is it, R1, 8.2.3. So we know that we have something going on here on this light bulb. We have the V parallel. Light bulb 1, there was V parallel, which was given that V, which is 32 volts there. is going to be the voltage across these two resistors combined. Already, I know that I have 20 volts here. So if I have 20 volts here, what is remaining here will be 12 volts. So VR1 is just 30 minus, what is it? 30 minus 20. That 30 or minus 20, that's going to be 32. 32 minus 20, which is what? Which is 12 volts. And then now my R1, using the formula I is equal to V over R, I know that R1 will now be what? A V over I. I know the current flowing through L1, which is 1.8. So I'm going to use that current. We know that these two are going to be sharing the same current, I1. So remember my I1 is right there. I'll just take it and use it. So V is what? V is going to be 12, and then I is going to be 1.8. When I calculate this, I'm getting an ohms. How many ohms am I getting? I'm getting 12 divided by 1.8, and then the answer is going to be 20 over 3, which is 6,67. I'm getting 6,67, and this is 6,67 ohms, and then we're okay with that. So that is it. We are right. And now we come to 8.3. Is that 8.3, 8.2.3, 8.2.4? Yeah. EMF of the battery, the EMF of the battery. So I know the formula of EMF is going to be what? EMF is V external plus V internal. I already have the V internal. The V external is the one that is lacking. Okay, it's going to be simple since V external is just V parallel plus V series. V parallel plus V series, and then V internal, we know the internal resistor and the current is the main current. So I'm just going to plug I and then V. What is it? This is going to be my IR internal, the small r. This is going to be EMF. And then my EMF V parallel, remember my V parallel was 32 volts. So I'm going to take that and use it to my advantage. So I need that 32 volts. I need the 32 volts. I need the 32 volts there. So I'm going to plug them here. I'll say 32. And then plus the V series, which is now the voltages across the 4 ohm only, because this, remember, this has no resistance. So A1 has no resistance, only 4 has resistance. So I'm going to plug the V series, which is going to be the current again. This is 3.3, the main current, which is flowing there. And then multiply by the, what is it? The resistance, which is 4. Then plus the current, which is 3.3 again, then multiply by the R internal, which is 0.6. And then now the EMF will finally be how much? Punching the calculator, I'm getting 32 plus 3.3 multiplied by 4 plus 0.3 multiplied by 0.6. And then I'm getting a 47,18. 47,18 EMF 47,18 volts. So it's okay. You can use the other, what is it? The other way. You can use that. We don't want to waste time already. EMF it can be what I, and then we know this is going to be R external, and then plus R internal. Some of you will prefer to first get the R external. Yes, it's possible. You can get your R external, of which you get the R parallel plus R series. So the R parallel, if you notice, you need the R through, what is it? Through the bulb L1, the R through the bulb L2. And then that's going to be it. If you punch the calculator correctly, after getting the R external, remember there's also the R series there. You're going to get your EMF is still going to be 47.18. I believe it won't change. So I won't go through that. Let's go to 8.3. And then 8.3, we have bulb L1 bends out after a while. Assume the resistance bulb L2 remains constant. So remember, they said the what? The resistance remains. So I'm going to look at L2. What is it? L2 still has the same resistance. So we know that we're given the power and voltage there. And I already know the current, so I need to remember the, what is it? L2 is still having the same resistance. Okay, so what am I going to do? L2, if this is bent out, what is going on? If this is this bent out? This is bent out. Um, you can notice that the current will now flow and then to come here, but it won't go through there since now there's no connection anymore. So this circuit is now a series circuit. So we have a series connection between 4 ohm and what? 4 ohm and bulb L2. So we now have a series circuit through the 4 ohm and bulb L2. 4 ohm and bulb L2. 4 ohm and bulb L2, they are now in series. So I can calculate my current. I believe there will be a new current since now we have a series connection only and we know the current has went down. So will bulb L2 still continue to glow? Because bulb L2 is rated 48 watts. Bulb L2 has its ratings 48 watts and what, 32 volts. And then we need to check if we'll still be able to give us, what is it? If we'll still be able to produce 48 watts through the L2. So let's go and check that out. I now have, what is it? I'm going to, they said what? Will bulb L2 continue to glow after bulb L1 burns out? Choose from yes or no. So when I look at it, current has dropped. So if current has dropped, it means that the voltage will also drop, and that is telling us that this will no longer operate as rated. So definitely the answer is no. So I'm going to perform a calculation and show now if I'm able to get the power across this to check and compare it as its rating. If it is less, it means that indeed that it will not glow. So now calculating the power. Power is going to be equal to what? Remember, I'm going to use the closest way possible, I squared R. Why am I using I squared R? I'm using I squared R because it has resistance. I can choose to use V squared R. So I'm choosing I squared R for a reason. The resistance remains the same. So I need to look out for my resistance of R. What is it? RL2. This was what? My current there, I remember, was 1.5. It's going to be V over, what is it? This is going to be 32 all over 1.5, which is how much? RL2. We know that R is equal to V over I. So there's no 32 divided by 1.5, which is 21.33. So 21.33, and this is in ohms. Okay, we are okay with that resistance there. Now we need to check the current flowing through that. It's no longer, what is it, 1.5? It was 1.5 back then. So I'm just trying to show you how now it has to remain constant. This was the previous resistance that we have. So it has to remain constant. It does not have to change. So now calculating my I through that, it's going to be now a different case. I can just go to, what is it? I think I can check out my V external, V internal. So V internal will still remain the same. I can calculate my I through the circuit, through the whole entire circuit. I can say this is going to be what? This is going to be V external all over R external. V external all over R external. And the V external in this case, how much will it be? Since we already have the 32 ahead and all that. If you notice the current that is there, and then I, so What will be my I? I will be, how much is it? This is going to be my I. Through the circuit, so what is it? V internal. When I look at the V internal, I will now know that that's where I can find my main current. So I will use that definitely to my advantage. So V internal is actually going to be my I multiplied by R internal. And the V internal, this V internal will not change. Will remain the same since the R internal still remains the same. So my V internal, as far as I can remember it, let me just check it out. It's 3.3 multiplied by 0.6. 3.3 multiplied by 0.6, which is the main current. Then the R internal is still 0.6. Notice that my current is still 3.3. That's my main current, 3.3 amperes. So now this will be reading the main current. So now 3.3, then all squared multiplied by the resistance, which is R. R is going to be what? 32 all over 1.5 to be accurate. And then I'm going to punch in and get my power. So calculating that, I believe this was my V internal. So I must not mix it. This was my V internal. Then I got my main current I. Then power will now be what? When punching the calculator, I'm getting 3.3 all squared multiplied by 32 all over 1.5, which the answer is now 232, 232,32 watts. And then now notice that if this is 232 watts, which is across that light bulb now, it's gonna definitely burn out. It won't be, what is it, glowing anymore. So it will burn out. There's no way it will continue to operate as usual. 48 watts to 32 watts. I mean, come on, let's differentiate the difference between the two. It's a very big difference. That power is too much for that light bulb. So definitely a no. The power is, what is it? Power of the, what is it, of the circuit now is greater than the power of the rating. So we cannot operate that. Bulb will not glow anymore. All right, thank you. That was it. And then now I can proceed to go and get my... there's nothing I need to get anymore. The question 7 is done, just like that. All right, I think that was enough. Thank you so much.